Can you link this one? ওটাকে বল প্রফেসর নিকি ভালপিদুর ওটা চালাতে এখানে এখানে Good afternoon. We are going to start the plenary session of the 45th conference of the Institute of Indian Geographers. Please come inside. I would request you to please come inside. In this session, we have 4 speakers. Out of these 4, 3 speakers will deliver their lectures online. The first one is Professor Niki Bhalpidu. She is a professor of coastal geomorphology in the University of Athens, Greece. After that, Professor Pavel Prokop, and he is a scientist in the Polish Academy of Sciences, Krakow, Poland. After that, we have offline Professor Sunanda Bandopadhyay. He is the senior most professor in the Department of Geography, University of Calcutta. And lastly, we have Professor Jayant Kumar Rautre, but I do not know whether he is joined or not. But we have invited him. To chair this session, we invite Professor Milabchand Sharma from the CSRD, Jawaharlal Nehru University, New Delhi. We'd also request Professor Sunanda Bandopadhyay to come on the dais. And rest 3 speakers are online. May I request Professor Milabchand Sharma to start the session. Now the mic is over to you.
Thank you, sir. Thank you, Professor Day. And good evening. Good afternoon. We have 4 speakers plus 2 additional speakers who are from the sponsoring agencies. The first 2 speakers are online and 2 are offline. Professor Bandopadhyay is with me right here, and Professor Rautre, if he's around.
He's also online.
Okay, he's online? No. Yeah, offline. Yeah, okay. And we have Professor Niki from Greece. She is a field geomorphologist, and she's going to take us to the field today. Niki, good evening from India, and I hope things are cold there as well. We have a very cold evening here in Shillong. Over to you now.
Although it is winter here, it is not that cold winter. So can you verify that you can hear me and also that you can see my screen?
We can hear you, yes.
And you can see my screen. I share my screen. You can see that, yes?
I didn't get...
She should, yes. Now she can start.
Okay. It's over to you now.
Okay. Hello, everybody. I'm happy to be here with you today, and I would like to express my thanks to the president of IIG, Professor Sunil Kumar, for inviting me. I will talk about exploring Earth's dynamic landscapes, virtual field trips in geomorphology. So I will take you in the field for a while. The scenery of the diverse landforms over the Earth's surface often surprise us and inspire us.
Niki, can you put this on full screen, please? On the right corner, there's a cross, so you can get rid of that.
The right panel.
Right panel?
People panel. people better.
Oh, I see.
Yeah, it's okay now.
Perfect now. Now it's all right.
Yes? Okay. All right. So the scenery of the diverse landforms over the Earth's surface often surprise us and inspire us to learn about their origin. A key question in geomorphology is the evolution of these landforms and the processes behind their evolution. Geomorphology contributes to the understanding of relief and landforms, to the prediction and mitigation of risks, and to the identification and exploitation of resources. The dissemination of knowledge of past landforms, changes and evolution is essential to raise awareness of various environmental issues and promote and preserve the geoheritage of an area. In this direction, virtual field trips can be a powerful tool as they offer a valuable indirect field experience, including the chance to visit or inaccessible places in landscapes and understand the evolution of an area that we cannot access easily. Field trips are the most significant and necessary part of geoscience, as geological processes can be visualized and understood. Geomorphological mapping, a very important aspect of every geomorphological works, also has a fieldwork as a necessary part of the process. And of course, for an integrated education in geomorphology, field trips are of vital importance. However, they have several drawbacks, the most common being the high cost and time needed to conduct them and the effort to organize them. This prevents many students from participating in them and many geoscience classes from organizing them. Virtual field trips, on the other hand, can be useful by everyone as they are free to access from any location. For example, from classroom, from home, one can visit any place, even a remote or inaccessible ones. Virtual field trips are a super tool to prepare for an actual field trip. Virtual field trips are a particular strong tool for geomorphology as it handles various environments which in many cases are very far destinations. So let's discuss about the virtual field trips versus the physical field trips. During the COVID we conducted two geomorphological lectures where instead of making a presentation or generally a typical lecture, we shot two field trips to two different students. We used them for our classes. The total number of the students were 150 students, and after the classes, we asked the students to fill in an online questionnaire assessing the virtual field trips. They were to answer yes or no to different questions, and here you can see some of their answers. Take a moment to see how many students were aided in the course of geomorphology through the virtual field trips, and how many would like to participate to another virtual field trip. Also, see how many students stated that if they were educators, they would choose virtual field trips instead of a simple presentation in their courses. Finally, I would like to emphasize this. Look how many students would use virtual field trips to prepare themselves for an actual field trip. And what we are doing nowadays that we don't have restrictions, restrictions and so on. Virtual field trips offers the students interactivity in comparison to traditional passive learning methods that can be used in the classroom. They can be used as means of preparation for actual field work, showing both the sites to be visited and the students' obligations when they visit the sites. These virtual field trips are very useful in visiting remote areas, as I already mentioned, and sites that are not accessible. And they are a valuable tool for disabled students who are unable to visit many areas. What is more, existing fieldwork can be improved by the means of a virtual field trip, as the same sites can be easily visited anew and more observations can be made. Exciting existing fieldwork can be with better beforehand preparation, with the panoramic observations, and for revisiting complex sites or locations. Additionally, we asked the students to freely comment on the overall experience. Based on that, we identified the main advantages and disadvantages for virtual field trips as experienced and testified by the students themselves. We finally asked them the question regarding virtual field trips versus physical field trips, and virtual field trips should not be used to replace field experiences. It is just another tool to the physical field trips. Here I will present some tools we have developed through which you can participate on a virtual field trip yourself. Here you can see our web platform, which is called the Geographers. This platform was developed by my group together with the Hellenic Survey of Geology and Mineral Exploration. From the initial page, you can scroll down and navigate in multiple field trips from many different places around the world. They are all in English, and they have been developed for researchers, geoscientists, and students. Here you can see some of the available virtual field trips. Each one of them is clickable, and then you can start navigating. This platform, in this platform, all virtual field trips are in English, and also you are very welcome if you would like to add your own virtual field trip there in order to make the platform even richer. Each field trip has been created in a different way using different tools, so we can always maintain the public's interest and keep it rising. In this example, we have used the Google Earth platform. In other examples, we have used GIS tools, and in some other in some other examples, we have given the opportunity to visit places through 360 pictures, Google glasses, or even through augmented reality. Here you can see many different examples from different geomorphic environments, coastal environments, tectonic environments, glacial environments, fluvial environments, and so on. Here you can see a different kind of tool for a virtual field trip based on story maps. It is based on GIS, and students may explore the evolution of different areas around the globe because of the sea level rise during the Quaternary. The development of the virtual field trips took place rapidly because many researchers worked and cooperated for this exact purpose. Very soon this platform has been used as a tool in many different universities around the world, such as Europe, America, Africa, and so on. And it was then that we started receiving comments from colleagues in primary and secondary education in Greece, and thus we created a button you can see here where you can find virtual field trips for schools. But in this part is yes.
Yes, your time is getting over, so please conclude. Yeah.
Okay. I have a few more minutes. Then there is a European project called GeoVT. It is an application which contains 360 photos and videos from various locations and aspects of geomorphology, which can offer a unique experience using virtual reality goggles, giving the impression of actually being there. And you can click on, you can visit the site, because over there you can find many different geomorphic environments from all over the Europe. Yes, and also you may find a platform where you can create your own virtual field trip, and you are invited to use that. And let me know if you have difficulties. We are here to help you. Imagine these virtual field trips in a virtual reality environment. You will think that you are in the place, in Sweden, in Italy, in Greece, in Malta, in many different places, and while you are just in home. Instead of bringing yourself in another continent, you can just bring a continent in your home. And there are many other different tools have used, like augmented reality. I will pass it through very quickly, but you have the links and you may visit it. And I would like to make a short stop here, which is something. It is a virtual field trip, but in a very different way, using augmented reality. You can simulate a flash flood in your classroom, in your house, in an area that you visit. With this app, you can see a real flood in a real time by using only your phone. This app is very useful in order to prepare for a real flood. You can use it while in the class or in your home, in order to run away in time before you are in a real risk. Here you may see an example that I used in my amphitheater, and my students flooded the place and me with them also. So here is the link. You can visit it, and you are very welcome to use it at your own classroom. As soon as you download the app and you install it, then you don't require internet anymore. And and finally, I would like to introduce you to our working group in the International Association of Geomorphology. It is a working group dedicated to virtual field trips in geomorphology. You are really invited to join us. We have colleagues from many different places around the world, and we would like really to see you there. Here is how you may find us. You can always visit the webpage of International Association of Geomorphologists. And finally, I would like to invite you to the regional conference of the International Association of Geomorphologists, which will take place in Romania next September. We have a whole session devoted to virtual field trips. Thank you very much for your attention, and I hope I have made you curious to participate in virtual field trips in geomorphology by yourself.
Thank you, Nikki. Thank you for sharing such an exhaustive information. This was excellent stuff for us. Thank you so much. Now we have Professor Paweł from Poland, please joining us. We don't have questions. Do we have any questions? No, we won't be asking the questions. Dr. Paweł Prokop from Poland, he joined us a while ago. Hello. He is there, yes.
Yes, my presentation is visible.
Yes, it is. Over to you.
Okay.
Greetings from Shillong, and I'm sure you are going to show us Shillong and surrounding area. So thank you very much. Good evening.
Okay, can I start?
Yes.
Yes, so my presentation title is according to the program, Land Degradation, Challenges and Sustainable Solutions, with a case study from Meghalaya. First problem which we have with land degradation is definition. There is no one definition of this problem. It is rather complex concept, which describes how natural resources are depleted or degraded. We should also distinguish between extreme event and land degradation. In contrast to extreme events, land degradation refers rather to gradual changes that occur over a relatively long period of time. So we have severely degraded areas which are very easy to identify, but it is much more difficult to estimate the loss of soil quality over hundreds or thousands of years. This influence also on perception of land degradation problem from the point of view of different scientific disciplines, which are look on the problem of land degradation in different ways. And here you have some examples. In forestry, for instance, land degradation is reduction in capacity of forests to produce carbon storage and wood products. And it doesn't matter if it is a result of anthropogenic or environmental changes. In ecology, we have land degradation defined as persistent reduction in the capacity to provide ecosystem service. Agriculture is concentrated on a loss of actual or potential land productivity or utility, also as a result of natural and anthropic factors. And also in social science, we have reduction in capability of the land to satisfy a particular use or social need. The differences are not only in the scientific disciplines. We have also differences in perception of land degradation between land users. When we look on the deforested parcel, we have to think if this land is degraded. For ecologists, for instance, this is terrible because all vegetation is removed. For forester, it is normal because it is forest management with 40 to 60 year rotation. Farmer can interpret this parcel as interesting because it is potential piece of land for cultivation. And tourists can be happy because it has a good spot just to take the good photo. All these things influence methods of land degradation assessments. Usually we use expert knowledge with using of various indices. These indices can be, for instance, intensity of soil erosion, some changes in properties of physical, chemical, or biological properties of soils. But the problem is always the same, the problem of comparison of the results. In fact, now we have two methods of land degradation assessment that can be compared at global scale. One, it is MEDALOS, the Mediterranean Desertification and Land Use Model. It was constructed in 1980s, but updated for estimation of land degradation at global scale and based on 4 indices. This is climate, vegetation, soil, and land management. And the newest approach is land degradation neutrality, which allows to estimate progress towards achieving land degradation neutrality by 2030. This is United Nations method and estimate land degradation trends in 3 indicators. First one is land use, next one is net primary productivity of land, and the last one is soil organic carbon. And this method I will try to apply it to the southern part of Meghalaya, because the conference is in Meghalaya. I think it can be interesting to see this method applied about 30 kilometers south of Shillong. The aim was assessment of land degradation neutrality using trends in these 3 indicators. It is land use, land cover, biomass of vegetation, and carbon stocks in the period 1965-2017. And for this, I have selected the study area. This is the Spur near Cherrapunji with highest rainfall in the world, surrounded by 2 deep canyons, and with 11,000 millimeters of rainfall. Soils are acidic, shallow, developed on sandstones and limestones. The natural vegetation is forest, but it is degraded to grasslands, which dominate land use and land cover structure. Population density is about 300 inhabitants per square kilometers. First, I started from field work and review of literature to identify the land use land cover types and driving forces of their change. And I have found that these driving forces are burning and grazing of vegetation, limestone quarry and settlement expansion, coal mine, which intensified in recent decades, and also the water reservoirs construction. I prepared 3 maps of land use land cover changes based on high-resolution satellite images from 1965. It is United States Corona, Indian satellite from 1998, and Google Earth from 2017. And if we see in this lower chart, we have very small percentage changes in forest and grassland, also in cropland, little higher in settlement, very high in case of mineral extraction, coal mine and limestone quarry, and water body. So we can summarize that the trends in the land use land cover change are resulted from the inherited from the past. Before 1965, when most of this land was deforested and degraded, and emergence of new driving forces of land use change after 1965. The method of assessment indicates that we should prepare a land use land cover change matrix between these two years, 1965 and 2017, with some clear type of interpretation of land use changes. There are two types of land use changes, in fact. One which leading to land degradation, one which are neutral, and one which are indicate improvement of land. And for instance, in case of the forest, any changes of natural vegetation like forest to any change to other types of land use is interpreted as degradation. So change from forest to grassland, cropland, settlement, fairland, or water body, it is always treated as land degradation and indicated by red color. In case, for instance, of grassland, conversion of grassland to forest is interpreted as land improvement. And the same is in case of cropland. In case of conversion of grassland to settlement or bare land, it is interpreted again as degradation. Conversion of grassland to water bodies has neutral impact on land degradation. And on the basis of this change matrix, it is possible to prepare very simple map of land use changes with degradation, neutral, or improvement. As we see, generally dominates neutral change, but with these changes which refer to change area of about 600 hectares between 1965 and 2017, dominate changes which indicate degradation. Next one is improvement, and final is neutral or no change. On the basis of calculations, land use change with vegetation, biomass, and carbon stocks done by our authors near Cherrapunji, we can calculate the loss, gain, and balance of biomass and carbon stocks. As we see, dominate loss, the gains is lower, and the balance of biomass and the balance of carbon stock for this area is negative. The loss of biomass and carbon stock mostly is responsible the conversion of forest to grassland and grassland to settlement. In case of gains in biomass and carbon stock, conversion of grassland and settlement to forest dominates. And usually most of the scientific papers finished with such result. But I think that it is important to show the ways of restoring of this land. This is very important because there are many attempts to reforestation of land near Cherrapunji during recent decades, and all have failed because there were no plants that can survive excessive rainfall during monsoon period, the droughts during the rest of the year, and also the burning and grazing, which is related to the human activities. So I think that the strategy to combat land degradation should be different. It should be based on the moving people away from the traditional activities and finding the alternative sources of income. It is very difficult way and very long way, but I can give some exams. For instance, investments of the government, doesn't matter if it is central government or Meghalaya government, the location, for instance, of National Institute of Technology in Cherrapunji can create new jobs. Another solution, it is tourism development. We have tourist visits to Cherrapunji region in recent decades, dynamically growth. But of course, as any business, it is very risky, and during the COVID, it rapidly dropped down, and now it is in a recovery phase. And something new, which is aquaculture, also promoted by local government, means the fish and aquatic plant farming. It gives also additional money to farming farmers, and also they change the diets of farm. And when we concentrate on conclusions, we can say that land degradation is a complex and subjective. It is influenced by diverse factors and perspective of experts, scientists, and land users. And there is no one definition of land degradation, and probably never be one definition of land degradation. But despite of growing awareness, standardized local methods of assessing land degradation are still needed. I have presented only one solution. We have, in fact, two solutions that exist. Effective assessment should include proposals for economically viable land restoration. It must be realistic. As seen in case of Cherrapunji, we have alternative livelihoods for the local populations. And finally, I think that land degradation is some positive impact on geography. It's rich physical and human geography through the use of social criteria linked to land use potential. So thank you very much for possibility of presentation. And some of the material which is presented in my presentation is already included in the paper. You can download it from the
Thank you, Professor Prokop. At least we could see. Thank you for showing us Meghalaya from Poland. Thank you so much for being with us this evening. Next speaker we have Professor Bandyopadhyay, who is going to speak on water 200 years.
It's okay, but you'll have to. Off. Put it off. I'll take this. Okay. The dignitaries and friends, when I was invited to speak in this conference, I thought, let me share that something on which we are working at present. And it's on the water bodies of Kolkata municipality, 200 years of change. 3 of my students are helping me for this, and one of them, Abhijit Das, is here. When we talk about Kolkata, and before that, if we just go to what I want to show, just a moment. Okay. The Lower Bengal land use change and water bodies. First, we have, please remember that is specific to the Lower Bengal region, and we have a pre-agricultural stage where we have no human intervention, forests and trees. Then the humans would come with the farmlands, and water bodies would start to emerge, mainly for irrigation practices. And gradually, human settlements would increase, and with them, the water bodies shown in blue. Water bodies are needed for drinking, needed for washing, needed for religious practices, a lot of things. And the mounds created by their excavation would be used to build houses so that they are protected during the floods. Then, the transformation to urban settlements would begin. Suppose they are beginning at some places, with the brick-built houses gradually, making their inroads to complete urbanization. With urbanization, we think of a lot of amenities. Piped water is one of them. So the use for the water bodies gradually disappear. And they mainly become important for ecological and other aesthetic purposes, nothing more than that. And when we consider the land economics, then it becomes far more economical for the local population to fill up these water bodies and convert them into something, a place for housing. In the Bengal villages, every village would have a water body or a pond associated with that house. Maybe every pond for about 3 or 4 families. Okay. So an rural land use means houses, orchards, and water bodies. What we try to see is that we know that the Kolkata, as we know the city today, is about 300 years old, and it was all basically an wetland by the side of it. It's not a wetland basically. It's the Hooghly River is flowing like this, as you can see. So it developed around its levees on the first, and then made their inroads into the eastern sector where there is a wetland called the East Kolkata wetland, and that made the eastern the limit of the growth towards the east for the city, but it started to grow towards the south. Now, it presently has about 4.5 million people in 144 wards, and the area is slightly more than 200 square kilometers. Okay, now basic objectives are quite simple. It's mapping of the water bodies in different years based on their availability, and the preparing a database of change, and finding out if they're in relation with the water bodies and urbanization process, and assessing some related issues like water logging and things like that. In this methodology, the most important part are obtaining the maps. We had 2 types of maps, right? One were for this ward body extraction, and another was for the water body extraction. We had a very detailed map of 1825-32, which is exactly around 200 years ago, and that maps are well known to the researchers of Kolkata, and they are called the Lottery Committee plans for the Kolkata city. Lottery Committee was an urban body that raised money from lotteries and used that money for developing the urban infrastructure. So they had an extremely detailed map of Kolkata on 1:12,000, that is 1 inch to 1,000 feet. Okay? After that, we have a Survey of India town map on the scale of 6 inches to a mile, that comes to close to that, 1 inch to 10,000. And then the well-known Corona space photos, archival images we have of the resolution of 2 meters. Then we had obtained some remote sensing, other remote sensing image that was LIS4, and we merged that with Cartosat 1.2.5 meters. That was, we formed a database at 2007, and then very recently we have obtained this Cartosat MX images, which has got the resolution of 1 meter. The interesting thing about this Calcutta city is that, like any city, its area grew. Okay, so there was one major problem that, see, these large-scale maps are available only for the cities, not for the other areas. But you can't see a small pond using a topo sheet. They won't be recorded. So you need at least a map of 1:10,000, scale. And that is available only for the core city, and outside that there is a problem. So with the evolution of the city, the growth of the city, as you can see here, our database had also had to grow, but of course it was, extent, but of course it was not possible during the map period. It was possible for the image period when we have remote sensing data. And as you can see in this bottom middle diagram, it shows the different stages of growth. And there was one problem, is that the ward boundaries also evolved, because we also extracted population data. And population data are only available for the ward boundaries. So when the ward boundaries evolve, it becomes very difficult to assimilate the population data. And as you can see here, I think this is not legible, this index, but even that thing which I have just shown, that particular square, that part, there are 3 wards that were added in 2012. And they were basically rural areas, and they helped us to, see what we have hypothesized at the beginning are working for the Kolkata city. As you can see, this upper diagram would be much easier to understand. It shows the indices of population and the urban area. In this case, the Calcutta municipal area, I remember one of my former speakers speaking, the meaning of the city is different. Guwahati can be, area, it can be municipal area, things like that, a lot of things. But here, I should have said that before, but I am only concentrating on we are concentrating on the Calcutta municipal area. That is the Calcutta municipality. And you can see they have grown hand in hand. Of course, the 2021 data is projected from 2021 and 2001, but they have gone hand in hand. The area increased, and as well as the population also increased. And these quickly show the problem we had in, when when wards assimilated together. For example, here the ward 45, this was formed by coalescing these 3. So that was not a problem. You can coalesce the population, but sometimes one ward, for example, the old ward number 5 was separated into 2 wards. Then we had proportionally divided the population into those 2 wards according to area, because there was no other way of doing it. Now let us quickly see some case studies of changes using the maps as images. I would start with Shambazar area. Many of you are not familiar with the Kolkata city, not important, but what I want to say is this, here are 3 wards, this Shambazar area, Narkeldanga area, and Taliganj area. The 3 wards, not 3 wards, an assemblage of wards, some wards, they formed the outskirt of the city at the beginning, okay? And then gradually, the city grew. City just overtook them like that. And the only ward from the very beginning, which was the center of the city, is the College Street region, where our university, the headquarters of the University of Calcutta, is located. Start with the northern outskirt. That is I'm sorry, the resolution of this screen is not very good, so you really may not be able to make these things out, but this is a very detailed map, and you would understand that the urban, the roads and the houses are much, comparatively denser in this region. Sorry, I will just have to put this. In this region, compared to the other area, it's more rural, this more urban. Then in this map, you can see it has turned completely urban. And again, here it's also urban, and this is the 2007 image, and then it is almost absolutely same with the 2023 image. Okay. Now, when we overlay the ponds, it becomes very clear that what I want to mean, all these urban fringe areas of 235 ponds now turn to just one pond at present. Okay, and similarly, this is the center of the city, the College Street area, and when we change the bottom right figure to 2023, it doesn't change much, but as you can see, there was smaller number of ponds right from the beginning, which is now, you can see only one pond in the entire locality. But again, to an outskirt, we can again see that here we have, not very familiar with this control, I'm sorry. Okay. You can see here, not this one, this we have already seen. Yeah. Here we can see a lot of greens here, right? That means this is a more rural than urban. And as you can see, all these regions have transferred into urban region, and the water bodies have also reduced in number. This large water body, what we see is called the Subhash Sarovar region. The soil or the material here were lifted to fill up an outskirt wetland of the Kolkata region, which is the today's Salt Lake City. It was partly used to fill that thing up.
You are reaching your limit, yeah, time limit.
How much time? 5 minutes? 1 minute just? Okay. So now what we have, so I need a bit more time. Okay, 5 minutes, please. Okay, then, so this changes like this. Okay. So it shows the same sort of thing. So we can just skip these things out. And now, here we see the whole thing, okay, the whole thing together. And it shows that the total number of water bodies, how they are changing. And what is interesting is that if you compare this figure with this, you will find that the things are migrating towards the south, okay? And this, and this, they are migrating towards the south. Now we come towards the end, and just we see this part at the south, and that is the newly added wards at the south. And you see, this is the 2000, and it's a 2023 image. And I don't have to explain geographers that the upper part is the standard FCC, upper part is all urban, the lower part is rural. And you can see, make out the water bodies there, okay? And you see, we have just extracted the water bodies and put them onto the 1964 image. And where we see there are no water bodies here, okay? There were no water bodies. So it really shows that the water bodies would develop with the progress of the rural settlements towards the area, and then they will disappear. And if you see this figure, then it becomes very clear, and that the density, it is increasing from 1941-42, and from that, only deviation is the wards 141, 140, 43 in those southern wards, where we see this as something like the density means number per square kilometer is something like 53 number per square kilometer and the 8 hectare per square kilometer, which is way above the other things. So basically, we could understand out of this that our main, what we wanted to show at the very beginning, that this is how that it will come should here. Anyway, so what we wanted to show at the very beginning, so that shows that, can we just see that a moment, my slide? Yes, that how the transformation took place in the city. So thank you.
Thank you. Thank you so much. Now we have the last speaker for this evening, or this session, Professor Rothray. I think he's going to be online, is he? He's not coming, okay. So we have, I think, presentation from the sponsors, two of the sponsors. So it's over
He's
to you.
not here.
Okay. So this is to thank all three speakers. Nikki for sharing this information on virtual field trip, softwares. So it makes life easier for us without going to the field. We can create things sitting at home. And Professor Pavel for showing us Meghalaya from Poland. Thank you so much. And thank you, sir, sitting next to me, for showing us how the water is going to be a crisis for tomorrow. Water is a crisis, but it is becoming serious now, with number decreasing of the ponds. Thank you so much. Thank you, sir. Thank you, President.
On behalf of the organizing committee, I thank Professor Milapchand Sharma for beautifully chairing this session, and it is perfectly on time. We have 20 minutes saved because we have 2 more presentations. And we also thank Professor Sunanda Bandyopadhyay, Professor Nikki Valpido, and Professor Pavel Prokop for their scientific presentations in this 100 Years of Geography conference. We thank you. Brief this appreciation. On behalf of the organizing committee, we'd like to May I request Professor Milapchand Sharma to hand over a token of appreciation to Professor Sunanda Bandyopadhyay. And on behalf of the organizing committee, may I request our Secretary IIG to hand over a token of appreciation to Professor Milapchand Sharma. Milapchand Sharma. Hey. Sir, 1 minute. चलो बोल दिया मैंने. Thank you very much, Professor Sharma and Professor Bandyopadhyay. We have a 10 minutes presentation by HIC Technologies, and he is Dr. Aparesh Patro, who did his PhD in our department. Now he is a CEO of the HIC Technologies. So he will give a 10 minutes presentation. After that, we'll continue to this Young Geographers competition, which is the most excited part of this IIG conference. So I would request you to be present, all of you be present here till the end of this competition. So may I request Dr. Aparesh Patro to come on the dais and present his presentation.
Good evening. I belong to the HIC Technology. It is a startup organization. So I'll take a couple of minutes about my organization, then we'll discuss about what type of work we have to do. So I am very much privileged because I studied this university in 2004. I completed my PhD with Professor Naik. And 2003, I joined the IIG because Professor Naik contacted me, the organization secretary that time. So after that, means 2 decades, I am joining IIG. So I'll take a couple of minutes about their corporate profile. So this is the startup organization. We started in the 2021, and we registered in Guwahati only. Though I am operating from Delhi, but intentionally I have done the registration in Guwahati because I have the long association with the Northeast. I know the culture, I know the people from this area. So I am very much attached to the people. That's why I intentionally did to develop something in these regions. So we are already registered in this, startup MSME already registered our organization. And then our visions and missions, so I will not go for this. So we provide the digital solutions in connection with the locational analyst, then artificial intelligence and machine learning, and big data and cloud. So our objective is static to smart conversation through our development that we want to do for our organization. So we have the partner, we are using all the source from the open source, and we have the technology partner Hexagon. Apart from that one, we develop our own software, own application as per the government's requirement. So these are the verticals: digital health, digital education, defense and intelligence, homeland affairs, environment, digital agriculture. All these verticals we used to work. And there are prospect cities, then smart city in Guwahati, Bodoland Territorial Council, Ministry of Home Education in Assam, and Ministry of Education in Meghalaya. All this area we are working. What binds us? Because today's date we have this all the full-fledged of systems, that we have the operation system, we have the marketing team, and we have the research team. All together we are working together. And this is the co-founder. So we have most of them are academia, and if you find most of them from geography department, originate from geography, they are helping us as an advisor or as a co-founder or founder. So those people are associated with us. I'm not taking much. And we started last in 2021. As per revenue is concerned, because when you are starting the startup, so you have to have the revenue. So last 3 years we have in the last financial we have done almost 3 crores rupees for the last financial year, and next this financial we are planning to 5 crores of revenue. So these are the 4 projects we have done so far in the Government of India. We have done from the BTC area and Bodoland area. Then we have done the POC for Assam, and that is the details on the health. The same project we have done in the Meghalaya also. And we have done one project in Sikkim under the RUSA. So that I will come in the detailed subsequent slide. So we have providing the modernization of agriculture, digital agriculture. We have the solution. We develop our own solutions. Let's say one organic farmers is there in the Northeast. So how this organized farmer there, what are the produce they are doing, how those produce can connect to the rest of the India. So we have developed one solution. So I'm not going to the details in the technology, just if you see the broad pictures. So provided to consumers. So all the details, we are taking care of all the farmers who have produced the particular product. Their products, their market size, their price, everything through software we enabling, so that farmers should not get deprived by the middleman. So our objective is farmers should get the proper price, and whoever the organization and the end user and farmer, there should be the proper coordination. So that software we already developed. So one of the project we have done from the tourism department, that is Bodoland area. We have already executed that project in Bodoland in Assam. So we have developed for the mobile app also that can be executed. Then Doha. This is our main objective, digital One Health applications. Actually, this came to our mind. We thought that, you see, the eastern zone is means totally hard to reach area. When any aging population, they want to get the service from the hospital, they do not get the proper services. Let's say I'm staying in the urban area, but my parents are staying in the rural area. I want to give the services. There is no proper services, no online services is there. But if you want to buy a pizza or you want to hire a vehicle, Ola, Uber, easily we can get it. So it is came to our mind, because this is the hard to reach area where the one patient coming to Guwahati takes 7 to 8 hours or 20, means sometimes it's an overnight journey or more than that. They do not have any kind of means prior information. They have to wait whether, when, how they will get the information, means they have to register in the hospital. So we have developed one platform where the hospital, means any patient, they can come directly to the hospital. They want to go to the diagnostic center, they can do the pharmacy or ambulance service, everything under the one umbrella. But this is our concept. But either this concept is correct or not, then we have done the thorough survey in the entire Northeast. So this is the result we have got. Then we found that most of the peoples, means they try to get their services at the home only. So we try to reduce that one, that can send to the people to the proper hospital, either it's a government setup or the private setup. That is our objective. And aging is a process, so you cannot stop them. But whenever the aging is coming, means any kind of disease will come. We cannot stop them disease, but we can reduce that disease to back. Let's say it is coming in the early 40s, we can reduce up to beyond 60s or after 70s like this. That is the objective. So we have done the POC in the Kokrajhat area with the collaboration with the government. Then I am coming to that area details how we want to do. You see, how the architecture is defined. You have taken the one small pockets, that is one particular point within the 3 to 5 kilometer radius. There may be 3 to 5 villages depending upon the nature of the landscape. So each and every people, they come to that sub-center, they register there one time. Let's say if you are a person, means patient, in your lifetime only one time you will register, then all the details will be there. Details in the name, your village name, your BMI index, everything. Means your height, weight, blood, everything is there. And any kind of treatment took place over the period of time, that will be registered only one time. But once you are going from that particular place to another place, so you no need to register all these things. The data will come to the doctors. He will see the only ID card, that ID. So now what we'll do, we are that ID card, we connected to the Aadhaar card. Nowadays, the Government of India introduced the Aadhaar card. So through Aadhaar, we try to get the data. So architecture is like this. Suppose once I go to the sub-center, if the doctors is capable, means whoever the doctors is available in the doctors is capable, yes, he can treat that things, then he can give the medicine and send back to the home. If it is not them, then he's sent to the PSC or CSC or higher echelon in the hospital. But if you go to the doctor, then you will find the doctor wanted to ask you have to do some sort of test. It could be the means your blood test or urine test, whatever may be test. But again, you have to go with somebody because you are aging population. You have to go there. Then you have to take the help from there. Means your person. So once you are going from one to n place, you do not have any kind of prior appointment. So that's why we prepare a environment where diagnostic center, doctors, individual doctors, hospital, whatever, government setup or private setup, they should come in the one umbrella. And once a patient come to that particular place, they can get the information, everything, and whoever the person, let's say diagnostic center, he will get the information, what are the test is required. He will not understand what the treatment is required. So those things we have already developed. So I'm not going to that. So these things, it is the interoperable with the mobile app also. And nowadays mobile app everywhere is there. If you go to the Pactro or 1MG, it is only for the urban area. But we develop for the rural area where the rural population get the access to this facility. So we have done in Meghalaya, just I'm showing you. And now I'm coming to digital education. We have done one project in Sikkim under RUSA. So under ICT-based development, as per the new education NEP guidelines, you have to have this ICT-based means solution. So in Sikkim, we connected all the government colleges only one platform, and we have given this kind of solution where digital locker will be there, digital library will be there, university management system, one system we have developed ourselves. Then this is the things OPS system, then because there is student-teachers communications. It is the both-way communication. We have given this kind of solution to them. And the hardware is not our part, but only the software part is we have developed. Then one option, we have developed our indigenous software. So we have given the solution, means it is not ArcGIS, not ESRI platform or Hexagon platform we have developed from the open source we have given in the cloud. There are 5 colleges, they can access the data. Even every college having their access control, admin is there. Any student, they can get the data, either it's a field data or whatever they create, the dissertation data, whatever may be, they can keep in their server. And these data cannot be shared by the other peoples. So those system already developed and it is deployed in Sikkim. So this is our objective, and just take it. University management system, all means education, means door entry to everything, means all systems in. That is means 6 lakhs to 16 lakhs difference. Depends upon the modules. There are 16 modules are there. So whatever the module you want to do, then get that you will get from there. Okay.
On behalf of the organizing committee, I thank you, Dr. Aparsh Patra, for his presentation. He is one of our sponsors. Sorry. So now the time is for the Young Geographers competition. I would request Professor D.K. Nayak. Oh, Nayak Sahab. Professor D.K. Nayak, I would request you to start the Young Geographers competition. And on behalf of the organizing committee, I thank you very much for chairing this session. Please come on dais and take over the stage. Thank you.
A very good evening to all of you. I think this is one session which most of you must be waiting eagerly, as we will have the young geographers presenting their papers, and it's a competition. So you know how tough the competition is. We received over 32 entries for this competition, very large numbers, and we had no option but to exclude quite a few by a process of selection which was very rigorous. 3-member committee went through all the papers and unanimously decided for only 7 which can be accommodated within this time span of roughly 2 hours. As usual, we will have 10 minutes allotted to each presentation. So you have to be absolutely on your toes to see that presentations are made perfectly in time, because each aspect of your presentation will be evaluated by a very distinguished panel of judges, and I request the judges to be ready in evaluating the presentations. In the meantime, if the presenters are all available, can you load your presentations? Is there somebody to help them? I request all the contestants to upload their presentations. Where will they upload them? Here in this? Okay, so please help them in uploading. We'll have 5 minutes in which you can do that. The rules are quite clear. 10 minutes of presentation. There'll be some kind of a warning which will be given to you at the end of 8th minute, so that you complete it within the time allotted to you. Then it will be followed by questions which we would expect it from the audience. And if there are no questions from the audience, then only the judges will ask questions. or even the inadequate questions, because we'll have 5 minutes for question and answer session, which will be all evaluated. How do you answer them, and what even the question quality will be also evaluated. But the question should be absolutely pointed. No further question should be only one question per person. No further, no dialogue between the presenter and the person who is asking a question. No prompting questions also, because there are at times, you want to help the candidates who are contesting here, and we tend to ask a question which will be prompting type. So don't do that. The questions will be absolutely to the point, not outside, and no large introductions to your question. The questions should be directly asked. That's for the audience. And the judges will be asking in case there are not many questions, and 5 minutes time will be available for question answer. And if that is not exhausted, then the judges will ask questions. Otherwise not. And what else would you like to ask? You can always ask. But let me first introduce our panelists. We have among us very distinguished, eminent geographers who would be evaluating. Professor Rajeshwari from Rohtak. Sorry, Kurukshetra, I'm so sorry. Then we have Professor Rambabu Bhagat, formerly with IIPS, but he has been now in too many organizations. And then finally we have Professor Lakshmi Sivaramakrishnan from Jadavpur University. So we have 2 women judges and 1 other than women. They are all good friends of mine, but very eminent in their own fields. They have contributed a lot to geography in terms of writing and speaking and attending various administrative and other responsibilities. I am so very thankful to each of them for having accepted my request to be the judges of this very important program. I don't think I need to say much more than this. So I request all the contestants to come and in 5 minutes load their presentations, and then we'll start immediately.